vector is magnitude and direction. So what is a resultant vector and a component vector? You actually know what these are already. We just haven't talked about them. But we did an example last unit, or I guess 2 units ago, where a person traveled forwards and then went backwards a little bit and then went forwards again. And we wanted to find their displacement, and their displacement was how far they went from where they started to where they ended. So resultant vector is the total vector value for all the components combined. So it's the total value of all component vectors combined. So the resultant vector is this green one. It's what we get when we combine all the smaller ones together. So components are the individual vectors that combine to the resultant. So these here are the component vectors. Okay, just some definitions we need to know, because I'm going to talk about these a lot, the resultant vector and the component vectors. So the components are what make up the resultant, and the resultant is what you get when you combine them together. All right, any questions so far? Okay. So, number 4. An airplane is flying with a velocity of 80 meters per second when it experiences a wind of 20 meters per second. Find the resultant vector for each of the following. Wind, the plane flies east and the wind blows east. The plane flies east and the wind blows west. And the plane flies east and the wind blows north. So go ahead and take a minute, and I want to see if you can figure those out. Okay? See if you can figure out what they are for A, B, and C. No, this is from yesterday. So it's 80 plus 20. Gives me 100 meters per second to the east. And that's what I get. So these are the individual ones, the components. Oh, I used the wrong colors. My bad. And then the resultant vector. Okay, so far so good. Who wants to try B? Maddie's. No, good guess though. You're close. Uberock? It is 60. How'd you figure it out? Why'd you subtract? Yeah, they're opposite directions. They're going at each other. So one's going this way, the other one goes back. I'm using my color mistakes again. So the resultant vector is from the beginning to the end, and that is a value of 60. Once again to the east. Do you need a notes page, or do you have it?
I think I might, need one.
I was going to say, you think you might have one? Need one? Go take that.
I'm not even listening.
Just so you still be kidding. Don't even know what you have.
I don't even know what's there.
I put 80 for the last one.
Who cares, Manuel?
Hey, hush. Let him try.
Try.
All right.
I got it.
Yeah, try. All right, what do you say? C, you said 80?
Yes.
All right, anyone want to try something other than 80? Let's just see what possible answers we got. So we got 80, 100, 70. Oh, that's 700, not 70. Yep. Others?
I'm hearing this, man. I'm just kidding.
Huh? 90? Okay. Okay, the answer is
80.
none of those.
I knew it.
So we need to come back to C because C is kind of tricky. So what's going on is it's this way plus this way. And that's not something we've done yet. We haven't combined things. We've done this, adding things in the same direction. We've done this, adding things in opposite directions. We haven't done this. So let's start with how to add vectors together graphically. So let's just start with basics. How do we add vectors together? So the way we add them is something called the tip-to-tail method. And it works like this. The first thing you do is you draw your first vector. So all you do is you just draw an arrow. Now you need to draw it in the correct direction, and you should try to keep the size in mind. So this is 80 and 20 are the two vectors. So it's 80 to the east, and it's larger than the other one. So I'm going to make it kind of big. Then draw the second vector. Starting where the first ended. So I draw my second vector where the first one ended. So it ended here, so I draw it north, and it's not as large as the other one, 20 meters per second. And then lastly, we draw the resultant vector. From the start of the first to the end of the second. So it looks something like this. And that's the resultant vector. Okay? So we are going to be drawing a lot of vectors, so I do want to make sure you can draw them. Yes? Yeah. The way we usually draw north, south, east, and west is like this. So north, south, east, west. So think of it like a compass, but you lay the compass flat on the paper. That's usually how we do it. Okay? Any questions on the front? Look at this. We're already ready for the back page.
Wait, I think it's 3.
Yep. 3?
No, like
Oh, the third step. Yes, sir. Look at you using your mathematical skills.
Okay.
All right. So how do we find the resultant vector in the angle? So here's what we have so far. We've got 80 meters per second east. We've got 20 meters per second north. We're finding the resultant vector. Maddox, what does that look like to you? Huh? It's the Pythagorean Theorem. It's a triangle, a right triangle. So A is the bottom, B is the vertical, and C is the resultant vector. There's also a value theta for the angle. We'll get to that a little bit later here. So if we want to find the resultant vector, we need to find the Pythagorean theorem. A squared plus B squared equals C squared. I know you woke up this morning and you said, oh, thank goodness I don't have to do the Pythagorean theorem, but you are wrong. You do have to do the Pythagorean theorem. Okay? But that's not bad. You guys have done that a million times before. You've seen it before. So that's not surprising. Here's what is surprising. We need to find the angle, because see how on these other ones we said it was 100 meters per second east, it's 60 meters per second east. We're trying to figure out what this one is. We have to know the direction. We can't. It's a vector. It has to have a direction. And saying northeast is not enough. or saying northish, eastish. That's not enough. We got to know the angle. We got to know the angle. So we need a way to find the angle. And the way to find the angle is, any ideas? Sine, cosine, and tangent. Oh, I know you guys were saying to yourself, oh man, thank goodness I'm done with sine, cosine, and tangent with geometry. Oh, you're wrong. You're not done. Or maybe you're saying, oh gosh, I haven't even gotten to that in geometry yet. Yep, you're right. You're going to do it now. Or maybe you're like, I'm not even in geometry. Why do I have to do this? And the answer is deal with it. So we are going to do trig. However, I have good news. Don't freak out. Don't freak out. I have good news. We're just going to do what we need. I'm not going to teach you how they work, why they work, what they do. None of that matters. What matters is, can you use them? And that's what we're going to do. So we're going to use one of these for the angle, and that one is tangent. So the equation set up is tangent theta equals opposite over adjacent. Now that is sometimes confusing to people because they're like, well, what's the opposite and what's the adjacent? So we're not going to use opposite and adjacent. We're going to stick with A, B, and C. Okay? Tangent is B over A. Tangent is B over A. Now, that also can be a little confusing because I'm not solving for tangent, I'm solving for theta. So I need to get rid of this tangent. Well, tangent is just a mathematical operation. It's like squaring or square rooting or multiplying. It's something you do to a number. In this case, the number is theta. Okay? So I need to do the opposite of that, and it's called the inverse tangent. So here's the equation you're going to use. So one of the equations you're going to use is a squared plus b squared equals c squared. The other equation you're going to use is this one. Theta equals tan negative 1 of b over a. Gavin, go ahead and close the computer for me. Okay, so b over a. So let's go ahead and do that example problem again. But this time, let's use the equations that we have. So going forward at 80, going north at 20, find the resultant vector c, and find the angle theta. So to find c, we use the Pythagorean Theorem. So a squared plus b squared equals c squared. So 80 squared is 6,400. 20 squared is 400. That's equal to c squared. Add those up and you get 6,800. Square root both sides. And you get c equals 82.5. So how fast is the airplane going? It's going 82.5. That's how fast it's going. So that's how fast it's going. It's going 82.5 meters per second. Okay? So that's C. Now we need theta. Theta is the other equation. Tan negative 1 equals b over a. So b is 20 over a is 80. And b is always the vertical, a is always the horizontal. Okay? So tan negative 1 is 20 over 80. I like to divide the numbers first. When I divide the numbers, I get tan negative 1 is 0.25. Then I use my calculator, so this is why you need one. And I'm looking for the tan negative 1 button. It's right above the tangent. I put in 0.25. You may have to put the tangent first. I hit Shift, tan, and there's my answer, 14.03. Go ahead and check to make sure you can get that.